Hey, hello. Yeah, in this video, I want to talk about centering, scaling, and standardizing variables in R. Okay, so this is some pre-processing of the data you have if you want to continue to do some subsequent data analysis. Okay, now first, let me set up the random seed on the generated data frame with several continuous variables, and this is what it looks like. So you can see they have different means and standard deviations. Um, so first thing I want to show you how to do centering. Center each variable, subtract the sample mean, actually. So we use the function scale. So scale of data, center equal to true, scale equal to false. So it has center and scale, okay? Center just means we subtract the observation by its sample mean, okay? So let's make it center around its own mean. And this is what it look like. And you can take a look of the sample mean for the center data. They're very small. They're close to zero, which should be the case. Okay. And the centering is a commonly used data pre-processing technique. Benefits of centering is faster interpretation of regression intercepts. Basically, after you center all the predictors, then the intercept become the um, kind of the average outcome after all the predictors are set as their average value. Okay, and also reduces multicollinearity in models with interactions or polynomial terms. So this is one way to address collinearity, okay, multicollinearity in regression models. Align 0 point to the mean or a meaningful value. Okay? Facilitate comparison between groups and across studies. Also, you can do scale. So scale basically just divide the variables by standard deviation without centering. Okay, so you do that, and this is what it looked like. However, if you try to calculate the standard deviation of each column of the scaled data set, they're not really close to 1. And this is because the scale function did not use the sample standard deviation. It used another standard deviation. So it's when you're not taking into account the centering, then you don't really get scaled standard deviation to be close to 1. Okay. But the benefits of scaling is it equalizes feature importance. So one variable does not dominate due to larger numeric range. Uh, Speeds up convergence for many optimization and machine learning algorithms. Improve model accuracy and performance for models sensitive to variable magnitudes. Makes coefficient comparable across predictors in regression models, prevents numerical instability in algorithms handling values of different scales. So basically, they're just putting all the variables on the same scale. Okay. All right. But the true strength of the scale function is that you can do both centering and scaling at the same time. And when you do scale and center at the same time, it's called the standardization. Okay. So basically, it could bring the sample mean into 0 and the standard deviation equal to 1. Okay. So you can do standardize the scale of data, the center equal to true, and scale equal to true. And this is what it looked like. So it should be very, smaller number, close to, I don't know, 0 and 1. So if the normally distributed is, then they should be centered around 0 with standard deviation of 1. And also, if you do this, you want to take a look at the standard deviation of standardized variables. Now you can see all the variances are equal to 1. Okay. Benefits of standardization ensures consistent comparable data across variables and sources. improves data quality by reducing errors and inconsistencies, enable better integration and sharing of data between systems or departments, facilitate accurate analysis and modeling by putting data on a common scale, supports faster, informed decision making and operational efficiency. Okay, so these are some of the simple pre-processing of data to really provide some benefits to the subsequent downstream data analysis. And you can do all this by using the R function scale. That's the take-home message. And if you like the video, please subscribe to our learning channel and click on the notification bell. I really appreciate your support. Thank you.